That's my own face there, that's weird. This is going to be... I feel like shit today. I think I had a dodgy cream cake yesterday and it's really fucking making me feel groggy. And my bumhole is like a raging inferno before we start. And I've got hay fever. So yeah, down in the doldrums. But I'm just doing a video I'm doing on shaft encoders from a PLC test rig series that is a collaboration with the whole of the ESK. This part is on shaft encoders that I'm doing now. And I feel like I don't fully understand shaft encoders myself. But that doesn't matter because I'm going to make it up. Not really. I'm going to learn about myself and I'm going to come on for the rest. So this video is in another video, like this. That won't make any sense unless you watch it on YouTube, yeah? This video is going to be another video. This is what I call it, you pick up a pickup shot, because the video you've made doesn't explain sufficiently, so you're going to add a bit in. So I'm going to do the pickup shot today. But what I'm going to do is, I'm going to make my own shaft encoder, and I'm going to do that using absolute bare minimum, like primary school level materials. So cardboard, hot melt glue gun, and just simple shit to try and explain to you and myself. There's two types. I think there's incremental and ultimate. I think there is. I think an ultimate one. Let me just Google this. Hang on. Right, so I didn't Google it. I went and watched Ledger Proof Reel on rotary encoders, not shaft encoders. I call them shaft encoders. Rotary encoders. He's got a good video on it. He uses a graphic in that video. There's absolute, which is like reading binary off a disk, so it can only read the binary in one place on the reel, and there's incremental. I'm going to make a model of an incremental to help the understanding of it. He uses a graphic in it, which is really good. It's a very good video. I think Daz from Logical Control's got a shaft encoder one as well. Go and check them out. But I'm going to make a model of an incremental one because there's a little bit I don't understand I want to get to. So let me go through that. Yeah, so for my own knowledge and for this video, I'm going to make an incremental shaft encoder model because I just don't get how it works. I think I know how it works in my head, but I want to see it. So I think there's multiple slots in a disc. There's some LEDs behind it, two of them that shine through. But the bit I can't work is how it works out to go to which way. So I think you have a dead spot where it doesn't see anything. And if you go in a certain direction, it sees one of the LEDs first. And if you go in another direction, it sees the other LED first. Thus, it can work out its direction of travel. I think that is how it works, but I can't quite work out if it can see one LED. I can't quite work out how it goes through to the next one. So anyway, this probably makes sense when I build the thing. So I'm going to the garage now. I'm going to build it out of the shittiest things I can find so that you could try and build one too. So we can play along at home, hopefully. Now then, here's how I understand it, yeah. If you think about it like a clock, I've got a clock. Let me go to the clock, that'll be easier. Right. This is how I see the binary encoder, yeah? A bit like this clock. So you see the rotation, which is the second hand. What would happen is the encoder would say back to the control system a series of numbers. So if we want to simplify this case, it'd go 35. And then it'd go 40. And then it'd go 45. So what that means is, because the computer reads the numbers, it sees the 30, the 35, the 40, the 45. So it knows when it's moving, how fast it's moving, and in which direction it's moving. Obviously, I can't make the second hand go backwards, but if it went 0, 55, 50, 45, it'd know it was moving backwards. You'd also know which way it was going. So hang on, what I'll do is this. Let me just do it to you. I'll be the shaft encoder, you be the computer. So if I say now, 25, 30, 35, I'm sure you can use those numbers to work out how fast it's going. It's fucking obvious it's a second hand. And in which direction and at what exact portion of the clock it was at when I told you those numbers. That is how I understand an absolute encoder running. Now, I believe they're hard to implement because you have to have you have to buy an absolute encoder which gives out the numbers. And then at the other end, you have to incorporate hardware and software that can read and decipher the numbers. Which is all numbers, it's database basically. Whereas with an incremental encoder, it just has holes and it goes past the hole and goes doink, 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 doink. But there has to be some way of it knowing which way it's going. And I'm going to try and explain that now. But I think, in my head, the absolute encoder that I just explained is easier but hard to implement. But the incremental encoder is cheaper and easy to implement. But the the Heath Robinson way it does things is a little bit more difficult to understand. So we'll try and do something that does that. That's what we'll try and do. First of all, we've got to clean the garage out. It's a shithole, so hold fire, I'll be back shortly. In case you weren't as well, we're making a PLC test rig, but I'm trying to make things that are more simple so you can play along at home, yeah? Because obviously not everyone's got access to 20 years worth of shit they've done while doing their own business. So what we've got is, I've got a cardboard box. Yeah, I get gusto, get over it, I'm a fucking big player. I've got a few odds and sods LEDs and resistors, and I've got a glue gun, which I think everyone, like Billy Basic, fanning around tools. So let's make, first of all, let's make a disc, which is going to be the encoder, and let's make a stand for that. In fact, let's make a few discs in case we fuck it up. Right, this cardboard box is a bit shonky. This inside bit seems to be quite, that's rugged. This is a bit shonky. Maybe I'll be able to make a disc out of that. I might split that, so I'm going to use this in a bit white bit for the stand, and I'm going to use the outer bit from a disc. So let's cut some discs out. Oh, fucking hell. Whoops. So the other week, I was cutting out some speakers, which were this big, and I put this hose on the inside to get this big. Now, start at all your standard sizes. This is actually a CK one. But this one's 142. It's probably the biggest one I've got. And it was off Amazon for 20 quid. And do you know what? I cut like 11 speakers out of that. When I first got it, it felt blunt as fuck. But once the paint came off, it weren't. And do you know what? That weren't that shit. So I'm going to use this for my discs. So I think I just run it through there by hand. I just put it through there by hand. Maybe I'll put it in the drill. Let's see how that goes. If I'm going to show you my drills, I'm going to need to go get a tripod. So I might go and do that now. Right. It's like Blue Peter. I'm going to use the white bit inside, because that'll be better for my discs. So I'm going to put discs on these, and I'll use the rest of it for my stand. I'm going to try and cut a disc out of it using this. Shall I just do it by hand? Shall I use the drill? I need to maintain the centre hole though. I'll use the drill. Rip my hand off on telly, hang on. Right, here's what I'll do. I'll put on a bit of scrap wood. I'll put the drill in so it maintains the centre, and I'll just cut it out. Here we go. Whoa there, little fella, that didn't work, did it? Because it's catching the cardboard hard. Let's try again. It's ripped the centre out of the hole. Look, now I haven't got a centre. Maybe I should do this off camera in case I kill myself. Hang on. So that's one bit of cardboard I've lost. Maybe I should cut it out with a pair of scissors. Maybe I should cut round it with a knife. Maybe I should have another go. Let's try and fold it over so it can't spin out. I've got time on the ground. I'm lifting the cardboard up into it. I did it backwards, so rather than cutting with the aggressive teeth of the old saw, I did it backwards, laying it off. So now I've got 1, 2, 3, 4 discs that I can use as my encoder. So that's my diameter. That's going to be my encoder inside. Now I need to make a stand for them. Just going to cut a piece of cardboard, make some triangles, and stick it on. Whack it together with a glue gun, I think, or some tape. Maybe some tape. Fucking tape. In fact, what I'm going to do is I'm going to keep this box. I'm going to cut a triangle out there so there's a hole and just put a rod through it. So I'm just going to cut the front out. I can keep all this. I don't need to get rid of it. Give it strength. So I'm going to mark a hole through there now with something. And I'm going to cut some triangles out to expose it. Or could I just cut another hole? Could I just cut a hole in that? No, it won't, because I need the centre of the shaft, so I'm going to cut a little triangle out around there. I'll do that. Change of plan. I was going to keep the entire box and cut a slot out there for it to go, and put a pencil for it and light my top. I'll do that. I'm just going to cut that out, look. Mark my centre. I marked, that's a hacksaw blade either side of the existing hole. So I'm going to open that hole out, and I'll put a pencil on my centre line and put a disc on it. It'll just spin then, that's all I need to do. I could even cut this down if I wanted, but I'm not going to. You know, back in the day, I'd made a wooden thing and gone at it, yeah? And spent ages doing it, and it would never have got done. It'd be another one of the unfinished projects. But now, like, I've got a hole, and my disc will fit in it, look. And if I get a pencil, which I won't have, or something round, hang on a minute. So I've just pushed a bar over it, look. Yeah, there's my shaft. Put it on top of there, look. And the disc will spin. And that's all I wanted it to do. Back in the day, I'd have sweated over that and made all the wooden one. It would have took ages, never got finished. But because I watched the Tim Hunky videos again, and on his prototyping video, this one.
Look at my own experience of making prototypes and the techniques that I find useful when making my machines. Though I guess I do hope it also may tempt other people to try physical prototypes in this digital age when everything's done on CAD. I think I'll just start with one of the simplest. When I was a kid, I used to make things out of cardboard and sellotape, and it's still very useful for making prototypes. The only tool you need is a pair of scissors really, and some tape. What I'm actually trying to make is a compartment to put your foot into for one of my machines. I'm not quite sure how it's going to work out yet.
He says just make it out of cardboard. Why make it? And it's wrong. So like literally I've been in here 10 minutes and most of that's been filming. So now I've got a thing. Now I need to work out how the holes in the shaft encoder go. So let's look at that. So on a real shaft encoder, these would be slits like that. And the reason the slits like that is because you can laser engrave that to very, very fine tolerances. But I haven't got that kind of fine tolerances in here. Now there were slits and I was confused about this. I couldn't fucking work it out. Because I thought what you need is you need a hole on the outside. It's maybe at the 4 points. They'd have an LED that shone through that. Then I thought you offset the hole. So they'd have an offset hole. So what I thought would happen, I don't think it's going to make sense to them, but this is just what I saw in my head, yeah? Say it was looking and it couldn't see through. Say it was looking here and it couldn't see through. If it went that way and hit that one, it'd know it'd be going to that way. And if it went that way and hit the high one, so if it hit the low one, it knew it'd be going that way. And if it hit the high one, it'd be going that way. But I know they're not like that. They're slits. And I couldn't work it out. I was bamboozled. So in my head it works like that if it goes that way and it's a high one, it knows it's going this way. And if it hits that one, it goes that way and it's going the other way. But I know they're slits. And I'm like, yes dog. I'm like, how the fuck does that work? Then I realised, they're slits. Dog, stop it. Hang on. These slits. Then I realised you could put the leads high and low. You could have a high and a low. You could have a low lead and off lead offset. Then I realised they don't need to be offset, do they? They could just be high and low. Because, dog. They're not all about this high and low thing. They don't need to be high and low. They just need to be offset. They can literally be next to each other. Because when the discs there look, you only see that one, which is 1, and then it moves to 2. And if it's on that one, and it moves the other way, that's how I see it. This is going to make sense when I make it here, I think. I hope. So what I need to do now is, I need to cut some holes, slits in, but I'm not going to cut slits. I'm just going to cut some holes because they'll mimic the slits for the purpose of this. So I need to cut some holes in one of my discs, which is what I'm going to do next. Then I need to put some LEDs behind it that look through, and I can play those LEDs and see how it works. But they are on the real one, they're slits, is the important bit. Right, so I've taken one of my circles, look. I've put a bit of wood, and I've drawn a circle around the outside. Then, I've took that same distance, and I've put it on the circle somewhere, and I've scratched it off. And then I've moved to one just scratched, and scratched it off again. And I've moved to one scratched and scratched it off again. Moved to one scratch off again. Moved to one scratch off again. Moved to one scratch off again. And that's given me a series of holes around the outside that are equidistantly spaced. They're going to be my holes from the encoder. I'm debating whether to make them half the size. No, I think that'll be fine. So that's what I'm doing now. Let me drill those holes. I'm going to put a 16mm hole saw through. I've got some Starrett Thinker ones I think will go through this without ripping it out of my hand basically. So I'll mark them. I'm going to make sure I mark this distance so I know what it is. So I'll put the hole in there and I'm just going to scratch an hole. Put the hole in there and I'm just going to scratch an hole so I know what that distance was. Right, I'll drill those holes off camera. Actually, not hard. What I've done is I've drilled my holes. You'll see there's an extra one. I'll tell you what that's in a minute. Just cut the first side of the cardboard. The holes come through the other side now. If I just drill from the other side, they should make the holes without clogging the hole saw up and without ripping the cardboard as it comes through the backside. So if I pop all them through like that, this is much safer than the big hole saw. So now look, I've drilled from the other side and I'm hoping. Yeah, that one's just popped out, look. That one's just popped out. That one needs a little bit more. Anyway, I'll get all these holes out. There you go. Lovely. And not clogging my hole saw up. Although that one, yeah, comes straight off. Drill the rest out. That one's come out. I'll do this off camera. It's fucking very, very boring. So now I've got all my holes in my cardboard, plus this extra hole here. I'm going to tell you about what that's for in a minute. And I've got something to hold my disc. I just need to make something that will hold my pen in the same place. It's not like, I don't want to use sticky tape, so I've got some spare discs now. Maybe I won't fuck these up. Maybe I'll only need this one, but that should go through there now, look. And if I put it on top of my box, they will be my slots. So now I can turn it round, look, and I get what I want. There we go. Look, obviously the pen's been round, so I just need to make a way of making that stay still. So I'll just do that, look, there you go. Woo! And that's going to help me explain. So I think we're about done with the cardboard. Literally 10 minutes that took. So let's find something to fix those things down right there. So what I've done is I've literally got 2 pieces of card and put them either side and I've taped it down like that, look. That's all I've done. So it creates a groove for the pen to run in. That'll be accurate enough for what I want to do. So I'll do it on the other side, that should stay there. So I'll tape that one down on that side like that now. I taped them down and I taped them down and I put a bit more tape in the groove, look, to act as a bearing. Rather than being cardboard, it's now that shiny aluminium tape. It's the ductwork tape, look. So now, look, that just turns. That's what I wanted to do. See how accurate it is. It's accurate enough for me, look, that is. If I go down the centre, there we go. Yeah, that'll do. That'll do for what we're trying to achieve. Now I just need to stick a bit of cardboard up here. So I'm going to need a back for it, and you'll see why in a minute. Because now we've got the holes for the shaft encoder. We need something at the back to shine the light sources through. So I'll just put a bit of cardboard up that. Cut a couple of little notches in it, look, to support the bit of card. Just taped onto the back. Now when I turn it round, I've used the red side, so I get a... where's the camera? There's the camera side. I've used the red side, so I get, look, you can see the red clearly through the brown now. There's not too much movement. So the first thing we're going to do is put the camera here. Is that looking down the centre? That's the centre there, look. There's the centre there. So let me mark where the camera is so I get the constant shot. Wait there, I'll do that. That's where the camera goes. So if I put the camera there, look, we're looking straight down it. And now that red hole is the top of that L. So I'm going to mark that. Now what I'm going to do is I'm going to line that back up. So it's there, look. I'm going to try and, whoops, mark the centre of that top hole. So I'm going to put a dot on it so you can get it right the first time. We'll see how we get on. But I'll make a dot so it's in the centre of that top hole now. There's my first go. So line up my centre hole. There we are. Oh, and my hole low, look. Try that. There we are. That'll do, look. So now my LEDs want to go here and here, off centre of that hole, separated by the distance of, I believe, these. Half a distance of the hole, I think. Let me work that out. Hang on. I think my holes on the LEDs on there need to be half a hole out, so you only see one at a time through that top hole. I think I've got this right. So now, look, if I bring it round to my known reference point, which is the bottom hole, look, I can see that dot. And then a half hole to the left, look, that's too low, but I'll move that up a little bit. And half hole to the right, that's there. So they both need to go up a little bit, look, you see. Just needs to go up a little bit. So up a couple of mil. And that one's to say, oh no, that one's about right, innit? It depends where the thing is, doesn't it? So if that's there, yeah. That one's about right. And that one needs to go up and left a bit. Right, wait there. I think I'm right now. This will get cut on YouTube. Sorry if you're on Instagram. Reference hole. The fucking camera focuses and that. So then, that's right. And that's right. So if you start off there, look, you'd see that one first. Then you'd see that one first. Then that one. But if you went the other way, you'd see that one first and that one. Now we need to make that. It's no good looking at dots. Let's put some LEDs in there and show you how an actual encoder works. This is going quite well. I'm fucking quite up with this. I need to bang some LEDs in it, so I'm just going to make some holes with a pen, put some LEDs in there. So we use a blue one for the home, a green one way, and a red for the other. So that hole size is what? Oh, it's a bit fucking what. I'm going to poke through there. So let's get them out. Often have to do a bit of soldering now. But let me just put the LEDs through. That might just work. I might not need to fucking turn them on, but it might be better if they come. But yeah, I'm just going to make some holes for them in there and put them in. When I find something that's that hole size. I found a skewer, look. So I've poked it in from that side first so I get the hole right. And then not going all the way through, I've just poked that side back. And now I think I should supposed to poke this LED in there. I can't do it from one hand. I got the chopper out. So I'm just poke the LEDs through now and see what happens. And I'm going to keep all the long legs to this side. So there's my LEDs in, blue, green and red. And I've got the long legs on the right hand side. Now I'm going to power them up. Because they're just not going to look right, are they? It's not going to give the view. So yeah, look. I've got to have to power them up, look, because it's just not going to... What's the fucking point? So, let's remember, is the long leg positive? I can never remember. So I need to power them up, solder the negatives together, and put a resistor on. So let me just do that for a second. That'll take me 2 minutes with a soldering iron. Right, I'm shit with LEDs, yeah, so I realised that blue and white ones need more milliamps to red and thing ones. So anyway, I swapped it for a red, a yellow and a green. So I can use the same resistor and 9-volt battery. If I click that 9-volt battery on there, they should light up and not blow up. Because I'm just not very good with electronics, to be honest. So I'm going to turn that round now, look. We have got 3 lit LEDs. And we can, let's take that off. There we go, can see them. So I've succeeded, well done. RLF vacuum cleaners will tell me how wrong I am. But I've used 3.3k resistors on them all, but I think I could use bright ones or whatever. I'm shit at electronics. Anyway, let me turn the lights off and we can have a look now, see if this actually works the way I intended. Right, I've had to adjust the LED place. I'm just going to put this behind here so it covers up the top 2 LEDs so we can only see the green one, yeah? So on most shafting codes, look like this. So on this bottom hole, look, you get a reference point. So now we can see green. Every time it goes round once, we get to see green again. Green. Green. So what that does is, that tells us that our disc, our shaft encoder, has done one full rotation of 360 degrees and it's got 1 notch per 360 degrees. So effectively that tells us that we are in the 0 position there, but then we could be anywhere we like, but now we're back at the 0 position. It does, however, count the revolutions, yeah, but it doesn't go any more data than that. The secret is from the other 2 LEDs. So if I just stop this video and go to the next one. So now look, I'm on the reference position, we can see yellow. If we go from yellow to red, we're going anti-clockwise. If the first leading edge is yellow and we get to red, we're going anti-clockwise. If we go from red to yellow, we're going... Sorry, if we go from yellow to red, we're going clockwise. If we go from red to yellow, we're going anti-clockwise. So if we put it in a dead spot, which is there... Hang on, let me write this down. So what do I think? Hang on, I think that if we go from yellow to red is clockwise. I promise not to cheat, I've wrote up this. So at the minute, I think yellow to red is clockwise and red to yellow is always anti-clockwise. If we put it in a dead spot so we can't see any, and I go anti-clockwise, the first one I see should be red, which it is. It's the first one I see because I see red first. Then I see yellow. I put it in another dead spot. And I see yellow first to red, yellow to red is clockwise, and that's what I've wrote on here, look. And that is how shaft encoder works, and now I understand it in my head. Red to yellow is anti-clockwise, yellow to red is clockwise. Put you back in here. Go to a dead spot anywhere on the wheel without the green reference point on there. So now we know that if we see yellow and we go to red, we're going clockwise and vice versa. Also then, we get a full rotation. So we see yellow to red. We know we're going clockwise. And there's the 0 point, look, because the green ones come on, yeah? Then we're yellow to red, 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 and there's set point. So now we've done 1 full rotation going clockwise. Also, they're spaced what? Or what degree is part they spaced? I don't know, but we know now we've got 1, 2, 3, 4, 5, 6 different increments. Hang on, let me write that on there and see if that works. So my 6 holes give me 6 increments. See between here and here, that's increment 6. See between here and here, that's increment 1. So it's 360 divided by 6. So not only we know we're at the 0 point now, and so we're at the 0 point now, look, and we see yellow to red. We're going clockwise, and we've done it 1/6 of the circle. Then we see yellow to red, 2/6 of the circle. Yellow to red, 3/6 of the circle. Yellow to red, 4/6 of the circle. Yellow to red, 5/6 of the circle. Yellow to red, 6/6 of the circle, and the green ones come back on. And now we know we can split our circle into 6. If I drill another hole in between these, I'll get 12. And if I drill smaller holes, 360, I could get 360 increments. And that is how I now finally understand, hopefully you do, how an encoder works. Right, I enjoyed doing that. I did enjoy doing that. And I've still got 3 discs left. And I can make as many as I want, right? So now I've got a 6 increment encoder. But if I wanted to, I could copy that circle that the centre of those holes is on, and I could make a much smaller one with more increments. I could make one with less increments, but to put that in my head, and this bit that just gives me a centre, that I honestly didn't really get it, and now I do. And if I'd not been recording that, I could have knocked that out in probably 15 minutes. But I enjoyed making it, and I'm going to keep that now and I put it down in the office. It's a good little sup dog. It's a good little stand device, so yeah. That's how an encoder works. The LEDs might be quite not right. The distances might be quite right. There's probably a lot more mass involved. But just for me, and obviously where I set you up so you could see them going red to green, green to red, I just enjoyed that. I know how it works now. That's all it needs. That's all it takes. Like, you can't argue with the physical attributes, can you, of it? You can't argue with the physical attributes. That if it's red first and it goes to yellow, you're going left. And if it's yellow and then red, you're going right. And every time you go all the way around through this zero hole, you're at your 0 point, and it works. Like I say, shut up, you fucking dog. So yeah, I could make it. I'm not going to now. I'm going to go and put this video together and edit it. But yeah, I enjoyed making that. It was nice to. I've been a bit of a thing of showing stuff that's way too complex, or showing things that maybe not everyone could afford or get. But I think you can all get a bit of LED, or get a bit of cardboard, a few resistors, a battery, and some tape. There you go. That's encoders. I'll go and slum us into a bigger video encoder now. And there it is if the dog could not bark. Just a baro, some tape, a battery, a couple of prongs. I haven't got a 9-volt thing, some LEDs, and then the mess around the back to make it work. So like I say, I didn't reckon him a cardboard, but I fucked a load of LEDs up doing it, look. So yeah, enjoy. Reasonably cheap to achieve. Quite enjoy doing that. Should do more of that. In fact, that's what I promised myself I was going to do more of. That's why I'm making a PLC test rig, so I could do more of this. Do things that I talk about, and then do basic things that anyone can make or deliver. Maybe as a STEM subject, something like that. So yeah, I quite like that, but I do feel like shit. I might go for a lie down now and a nice cup of tea. Done barking now then? Yeah, you done barking now? Have you finished barking? You silly sausage.